So today's concept is with the indexes. Okay. So here we have a concept of sequence. Nowadays, no one is using the sequence. Earlier, we were using sequence concept with to generate the incremental knowledge. But nowadays, no one is using. Think from past 4 5 years, I've not used it. Before that, I've used it. I've used it once, but now nobody is using it. Okay, and even no one is asking in interview also. Okay, so that we'll check later. So indexes. So basically we have a concept of indexes. So these indexes are being used to speed up the SQL statement execution on a table. Okay. So basically how indexes are going to work like. So we have an index page in a book, right? Okay. So for every book where we'll be having an index page, like which chapter is present in which page. Okay, which concept is present in which page. Okay, so that if you have an index page, then it will be very easy for us to identify which chapter that we have to open. So if you don't have any index page in a book, if at all we wanted to navigate to a certain chapter, then we have to search every page. We have to search every page. So then only like we'll be able to identify this particular chapter is present in which page. Okay. So in the same way, indexes also are going to help us to improve the performance. Okay. So whenever we define any index on top of any column, okay, so that is going to be so that is going to help us like so this particular record that I'm looking for is present in so and so place of the table because let's say the table is having millions of data. Okay, so when the table is having millions of data, when we write a select statement to fetch where department number equal to 10 like that. So now department number belongs to which all the records. Department number 10 is belonging to which all the records. That ideally, so if you don't have indexes on top of a department number column, then it is going to do a full table scan. That means for every record, it is going to verify whether this particular record is having department number equal to 10 as 10 or not. Okay. Similar, if we have defined any index, it's not going to check for each and every record. It will automatically identify. So these are all the places where we have department number as 10 record. Immediately, it will give us. So these indexes are going to help us only when the tables are having very huge volumes. Okay, and to improve the performance of an SQL. Okay, whenever we wanted to improve the performance of an SQL, then we are going to create indexes. Okay, so there are several types of indexes: unique index, non-unique index, B-tree index, bitmap index, composite index, function based on cluster based. So function based on cluster based, these two indexes. So just for mentioned for interview purpose. Okay, but these two functions that as a developers we are not going to use them. So these are going to be created by the admins. Okay, so this is at this they are going to define at the cluster level or uh, any user defined functions we have learned, right, like row level functions. So if at all there is any function which is being used commonly across the organization and that function is taking more time, so then the index will be created on the particular function. Okay, so function based and cluster based indexes will be used by the admin team. Okay, and unique index. So unique index. So this unique index, whenever we define on top of any column, so it will make sure there is no duplicate values. So whenever we create any unique constraint or a primary key constraint, so this unique index will be created in the backend. So because of this unique index only, so those two constraint unique or primary key won't allow any duplicate values. Okay, so in the backend, whenever we define these two constraints like primary key or unique constraints, in the backend, this unique index will be created on top of these two constraints. So because this unique index only will not allow duplicate values into those columns whenever we define primary key or unique constraint. So it's not like only primary key and unique constraint, this unique index will be created. Even we do create, we can also manually create unique index on top of any column. Okay, so there is no hard rule that we should use this unique index only on only with the primary key or unique constraints. No, it's not like that. We can explicitly create unique index on top of any column to eliminate the duplicate values. Okay, so non-unique index is the general index. Okay, non-unique index is the general index. So that we are going to create on top of any column. Okay, so out of all other constraints, sorry, all other indexes, this is the normal index. So this actually the non-unique index, it is not going to impose any roles. So you impose any restriction on top of the data, because if you create unique index on top of any data, on top of any column, it will make sure it is not allowing any duplicate data. Okay, but if you define non-unique index, so then it's not going to apply any restriction. Okay, so this non-unique index got decommissioned somewhere Oracle 9 version. Okay, but so because ideally it was the default index, but now B-tree index is the default index. Okay, whenever we just create index name, it will create with the B-tree index. So this B-tree index is the is going to give is going to be used for performance improvement.
Bhaskar, sorry, Bhaskar, are you sharing your screen because I couldn't able to see?
1 second, let me share my screen.
Thanks, Bhaskar.
Oh, thank you, Alibi. So this is about unique index, non-unique, and B-tree index. So B-tree index is the default type of indexes that Oracle by itself is going to consider. Okay, so when it is going to be used for the comparison, see, majorly these indexes are going to be helpers, as I mentioned, for the performance improvement. So when the performance improvement, so when we are using tables, multiple tables in join condition, okay, so when every join is happening, so if indexes are not there, every record of first record of table A is going to compare with all the records of table B. If at all we have any indexes, so it's not going to look each and every record. Okay, so it will automatically identifies. So in which place this, which all the places where this particular matching value is there. Okay, so because of that, it is going to eliminate as many as number of rows for every single execution. Okay, so that is the power of indexes in Oracle. Okay, so the next one is bitmap index. So this bitmap index will be used on a low cardinality columns. Low cardinality column meaning, so in a column where too many duplicate data is there and very lesser number of unique values are there. Okay, whenever we are creating any index, the only thumb rule that we will have to say is what is the column that we are creating. If at all a column where we are creating index which is having more duplicate values and a very lesser number of unique values. Let's say we have a status field. Okay, status field, it will be active or inactive. So for every record, the status will be active or inactive. Only two values will be there, but those two values will be there for all the records in the table. Like we have millions of data, all the millions of data will be having the status as either active or inactive. Okay, so these kind of a columns, like we'll be putting a filter in a join condition. Sorry, we'll be putting a filter in a way in a where class that where status equal to active. Okay, we want it because we have a requirement to fetch only the active records. Okay, so in this case also we are going to create index on top of a column which is used in the where condition. No, such kind of index, such kind of a columns where we have to create bitmap index. Okay, otherwise we are going to create a B-tree index. If not, we are going to use bitmap index. Bitmap index will be created on low cardinality columns. Or we have a gender field. So in the gender field where we have only male or female, only those two values will be there. But those will be there for all the data in the database. Sorry, all the data in the table. So when we are putting a gender condition, when we are using gender field in a condition or gender field in a where clause, so then we are going to use bitmap index. Bitmap index will be used to fetch, sorry, to get the data faster when we have very less unique values and too many duplicate values. So that we will in a real-time world. Okay, so in a technical world, we'll call them as low cardinality columns. Okay, so and composite index. So composite index is basically, see, composite index is nothing but index will be created on combination of two or more columns. Okay, any index, either bitmap index or a B-tree index, any index that we are going to create on top of two or more columns, that we will call it as composite index. Any index will be created with two or more columns, then we will call it as a composite index. Okay, so these indexes I did not show here because, so even here it is not going to give any improvements here because we have very less data. So indexes will be the actual performance of indexes or actual usage of indexes that we can see only when we have millions of data. Okay, so this is just for interview purpose. You can learn. This is for interview purpose. We can learn these index concepts. Okay, what is B-tree index, what is bitmap index, and what is composite index. Okay, so the next topic is query tuning approach. Okay, so this is one of the very important interview question. So without this question, there will not be any interview. Okay, there are certain questions where for every interview, this mandatory questions will be there. Okay, out of that, this is one more question. Query tuning approach. See, basically how they are going to ask is, so we have an SQL query which is taking more time. Okay, which is not returning the data quickly. Then how are you going to improve the performance of that SQL? Means that SQL is working for is running from past half an hour or 1 hour. Okay, but now I don't want that to be executed for half an hour or 1 hour, but I wanted to execute within 2 minutes. Like I wanted that to be completed within 2 to 3 minutes. How will you make this SQL faster? Okay, so for that, this is the solution. So basically, when we are working as an developer or when we are writing an SQL statement, okay, so there are certain rules that we will have to follow. Okay, so whenever we are going to execute any query, so that query first we will have to execute in a explain plan. Okay, so if you go to database, okay, if you go to, let me write one simple query. By Okay, so I have a join condition here. I have a query with join condition. Okay, so majorly the queries will take more time only when we have multiple tables in the join condition. Multiple table joins. Whenever a query is having with multiple table joins, so those queries only will take more time. So in this case, what we should do, first we have to execute this select statement, the big select statement that we will have to select it and we will have to run it in the explain plan. So I have placed the cursor here. If you see, explain plan is here. So there is a button, run script, and the explain plan. Okay, we will have to run that in the explain plan. So when we run it in the explain plan, we can see the statistics of the SQL, whatever the SQL that we are running. So for that, we are seeing the statistics. Okay, what kind of statistics that we'll be having? So what type of joins are happening and how what is the table access, like whether it is a full table access or any indexes are there. Full table access or any indexes are there. Okay, what are the any? What is the cardinality and what is the cost? So the cost and cardinalities are going to decide based on the number of rows and based on the join conditions. Okay, if cost and cardinalities are more, very more, or too much, like if they are in thousands, it is okay. If they are not in thousands, if they are in lakhs, or if they are more than 10,000 like that. Okay, so then that is a blocker. So that is taking more time. So this cost and cardinalities will be decided based on the columns that we are using in the join condition and based on the number of rows that is being displayed and based on the data that is there in the tables. Okay, and if at all any duplicates are there. Okay, if at all, when whatever, see, ideally the thumb rule is whatever the columns that we are using in the where condition or in the join condition. So any one table should have unique data. Both the tables should not have duplicate data. Okay, any one table should have unique data. Okay, then only the cross join is not going to happen. Otherwise, the Cartesian product is going to happen if both the tables are having duplicate values based on the join condition. Okay, so if at all any duplicate values are there in the join condition, in both the tables, we need to make sure at least one table is giving unique data. One table is giving unique data. So, so that if at all any duplicates are there, so here in the explain plan, we'll be able to see so what type of joins are happening, whether the what is this option, whether it is doing a full table scan or it is index created. Okay, now we don't have any indexes on top of this column. Okay, first by seeing this select statement in an explain plan, we can see cost and cardinalities. So here we are going to see for all the joins, whatever we have. So based on this joins, we will have to take a decision. Which join is taking more time? Which join is taking more time? So here we have only one join. Let's say we have another table join. So one more hash join is going to come. Here, this is one hash join. For this hash join, this is the cost and cardinalities, and these are the tables that are involved. If at all we have one more table join, so that table join will be coming as one more hash join here. So like that, how many number of tables that we have, those many hash joins will be coming in the explain plan for all the joins whatever we have here. Okay, so as I mentioned, right? So if the constant cardinalities are more than 1,000 or more than 10,000 or below 10,000, it is okay. Above 10,000 is not acceptable. Okay, first we need to see which all the joins are having constant cardinalities are more. Which all the joins are having constant cardinalities are more. So we have to see the performance improvements on those joins. Now, what are the steps that we will have to take? Now we have executed the query in the explain plan and we have seen in which all the joins are taking more time and what is the constant cardinalities of each join. Now once we identified that, so these particular joins are having more constant cardinalities. So then we need to see whether the relevant indexes are created on top of the join columns or not. Okay, so either B-tree index or bitmap index or bitmap indexes are created on top of the columns that are being used in the join condition, whether really any indexes are there or not. Okay, if indexes are not there in the join columns, so we will have to create indexes. So that is the reason it is always advisable. It is always advisable to create indexes on top of the columns that are being used in the join condition. So which is going to improve the performance of an SQL statement. Okay, if join column does not have indexes, then it is going to do a full table scan. So if full table scan, then the cost will be more. So then we will have to create indexes on the joining columns. So it's not like so we are going to create indexes on any column in a table. No, it's not like that. So we have to create index only on the join columns, the columns that are being used in the join condition. Okay, now once we create indexes and when we execute, so there will be improvement in the SQL statement. So now still, let's say no, it was taking 30 minutes. Now it came down to 20 minutes. But these 20 minutes are also is not acceptable. Okay, this 20 minutes also is not acceptable. Now still again we will have to reduce the time. Okay. So the next thing is we will have to gather the statistics. Okay, we will have to gather the statistics of the tables that we are going to use in the join conditions. Which are the tables that we are using in the from class on top of all the tables where we will have to gather the statistics. Gather statistics meaning so when we gather the statistics, when we analyze the table, okay, we will have to analyze the table. Meaning when we analyze any table, what is going to happen is whenever we perform any DML operation on top of any table, so sometimes what is going to happen, these commits and rollbacks that we are not going to follow properly, or when we do any deletions, so there will be temporary in every table where we'll be having a temporary memory and a permanent memory. Whenever we perform any DML operation, so first the transaction is going to happen in a temporary memory, and once we are going to pass either rollback or commit, then the transactions will go to the permanent memory. Okay, if at all there are any blocks in the temporary memory, okay, so those temporary memory blocks are going to occupy some those blocks are going to occupy a memory, and which is going to cause our performance of the table. It is going to cut down the performance of the table. Now when we gather the statistics or when we analyze the table, okay, when we analyze the table, then all the temporary blocks will be removed from the temporary memory. Okay, now the table will be fresh and clean table. Okay, so we have to analyze the table to gather the statistics so that all the temporary blocks will be removed and the table will become free. See, sometimes what is going to happen? So whenever we are creating this, whenever we are executing this, so when we are using these join conditions, so it is going to occupy the table memory. It is going to occupy the table memories. When it is going to occupy the memory, so if these temporary blocks are already occupied more memory, and when the runtime select statement also is going to occupy some memory, and that memory is going to throw an error because sometimes okay, it is going to throw an error like unable to extend the temp space. Okay, the temporary memory unable to extend the temp space. Okay, so that even though we have more memory in the database, still we are going to get an error stating that unable to occupy the temp space because the temporary blocks are still not clear. So when we gather the statistics, all the temporary blocks will be cleared and the table will be crystal clear, so that which is going to improve the performance of this table. Okay, now from 20 minutes to 10 minutes after we analyze all the tables, then from 20 minutes to 10 minutes it came up, but still this 10 minutes also is not acceptable. Then the next option is creating hints. Okay, so hint is nothing but a clue. So for the select statement where we will have to create a hint on top of a table. Okay, in the select statement, whenever see immediate after select, whenever you see any existing SQL hash star, the hint name star hash. So this is nothing but a hint. Okay, between select and the first column, whatever the value that is going to be there with hash star and star hash. So in between that, whatever the value which is there, so that we will call it as hint. Okay, so these hints are going to help us a lot. Okay, because these are the clues that is going to be given to the select statement to fetch the data quicker and faster. Okay, so there are several types of hints that we are going to have. Okay, out of that, So one of the major hint that we are going to use it is parallel. Okay. So in the select statement, if you are going to write hash star PARALL parallel of star hash. Okay, parallel of. So what this parallel hint is going to do, which is going to create parallel sequences. Okay, parallel executions. So by default, the select statement will be having one node, which is going to execute one thread, which is going to be used to execute this select statement. What this parallel hint is going to tell? Parallel of 10 meaning 10 threads. So we are giving an explicit intimation to the select statement that create 10 threads for this select statement. Create 10 threads for this select statement. So all the 10 threads will execute in parallel in the backend. So the performance of this SQL statement will be improved 10 times. Okay, but so sir, it is going to give performance improvement by 10 times. So why don't I give 20 threads or 30 threads? No, we should not give like that. Okay, why? Because how many number of threads that are going to be increased by the select statement, so that much of memory is going to be occupied by the select statement alone. Okay, so that the other SQLs, people who are executing other SQLs, those SQLs will be get hanged, because the RSQL, whatever we are executing, this SQL itself, it is occupying all the memory. Okay, then the other people also needed the database memory, right? Okay, if our query itself is taking more memory, then how other people are going to execute it? It will be very difficult for them. So again, so the DBA will verify the stats, who is occupying more memory. Then they should not come to us and say that, so boss, why are you using this SQL and this SQL is occupying more memory? We are going to kill that SQL, because in real time, so if that SQL is executing in production, and if business says that, if the DBA says that we are going to kill the session, then we are not able to pick the proper data. Okay, to avoid that kind of a situations, so we have to be very much careful about giving how many number of threads. See, ideally 5 to 10 threads that we are going to give. 5 to 10 threads are not going to cause any issue. If it is more than 5 to 10, then we'll have to see. And or we need to have a clear justification, because I wanted this SQL is taking 2 hours of time or 3 hours of time. So but business is telling that this has to be completed within 5 minutes or 10 minutes, then this is the only option that we have. If I have created indexes, I have gathered the statistics, still it is taking time, so then this is the only option that I have. So that is the reason I'm using 20 parallel of 20 or parallel of 30. Okay, so then what DBA is going to do? They will take the SQL, they will see the performance improvement. They'll see the performance improvement steps. Okay, so whether the join conditions, as I mentioned in the first step, whatever the columns that we are using in join conditions from two tables, based on this column condition, at least one table should have unique data. Let's say in employee table we have many departments. Department 1 is repeated, department 2 is repeated, department 3 is repeated. But department table, we have only only department number 1, only one department number 2, and only one department number 3. Okay, it's like that. Any one table should have the unique values, and the other table can have duplicate values. If both the tables are having duplicate values, then the query performance is going to be hit, and we are going to get wrong result. Okay, ideally we should supposed to get 6 records, but we are going to get 100 records because there are duplicate values. So that's why we need to make sure whatever the column that we are using in the join condition, so at least one table should have unique values. Okay, so these are the advantages of these are the steps that we will have to follow when we have to improve the query tuning, like when we have to improve the performance of an SQL. So in the interview also, when people are going to ask, you have to tell the same. Any questions? Anyone having any questions?
No.
Others, Jayantani Vishwan Nirupa.
Bhaskar.
Okay. So with this I can conclude the complete SQL is completed. Okay. SQL is completed and the rest of the questions are for your interview purposes. Yeah. And one concept is row ID and row number. Okay. So whenever we create any table, for every table where we'll be having a pseudo columns. The pseudo columns are row ID and row number. So row ID is an unique identifier of every record in the entire database. So if one row ID is assigned to one record, so that row ID will not be assigned to any other record in the entire database. Okay. So for every table, these two columns will be there. But when we execute select star from a table, select star from table, we won't get it. Select star from table, when I execute, I'll be getting only the columns that we have created, right? But when I explicitly mention row ID, I will be getting the row ID values. Okay, because this row ID value is an unique identifier that will be generated for every record in the database, entire database. Okay, for every table and every record, this row ID will be created, and this row ID will never change in the database. Okay, if at all we delete this record, this row ID will be get deleted and it is not going to assign to any other record. Okay, so this we will call it as a pseudo column, and we have a row number. So row number is a sequence number 1 2 3 4 5 sequence number. Okay, but this is going to whenever we delete any record, so then the deleted sequence number will be assigned to the next value. Okay, so this row number is unique to the table, but this row number is unique to the table only, not at the database level. For every table where we'll be having row number, and this row number is going to give sequence number 1 2 3 4 5. This row number is going to give sequence number 1 2 3 4 5 6, like it's going to give. Let's say if I'm going to delete one record number 2, so then this 2 will be assigned to the next record. Okay, but this row ID will not be assigned to the next record. So this is the difference between row ID and row number. Okay, so row number is a sequence number which is going to be unique at the table level, not at the database level. Row ID is a unique identifier which is a alphanumeric value, 16-digit alphanumeric value. Okay, and this is unique at the database level, entire database. And once one row ID, once it is assigned to a record, this will not be assigned to any other records. And sometimes we are going to use this row number also in a where condition. When we use row number, we should be very much careful. Okay, row num equal to operator is going to only work for 1. Okay, row num equal to 2 won't work. Row number equal to 1 only, it will work. Okay, row number equal to 1 only, it will work. Row number 2, it won't work. It is not going to give any result. Okay, row number 1 only.
Why, Bhaskar? Why 2 won't work?
Yeah, that is a functionality. That is how they have designed it. Oracle is designed like
2, 3, 4, 5, nothing will work. Only 1 will work, you are telling.
with equal to operator. With equal to operator, only 1 is going to work. With less than or equal to, less than, greater than, with that all others are going to work. Row number less than or equal to 1. Let's say row number less than or equal to 2. They are getting 2 records. Okay, greater than or equal to greater than also is not working. Less than or equal to. So row number less than or equal to, or less than also I think work. Okay, so less than or equal to, it is going to work. Greater than or equal to or greater than, it's not going to work. Okay, but this is a very rare situation where we are going to use the row number. But yeah, so this is for interview purpose we should learn. Okay, because this is a little tricky, right? Row number if you are using in a where condition, what is the default, how many number of values that we can keep it. Row number equal to 3 is going to work or not. Row number equal to 5 is going to work or not. Row number equal to 1 is going to work or not. So like that questions will be coming in interviews. So for interview purpose, we should learn about this row ID and row number. Okay. So this is about row ID and row number, and where class and having class, what is the difference between them, and what is the difference between subquery and a correlated subquery. So all these things that I have explained when I was telling the respective concepts. And as I mentioned, so here I have important queries. Yeah, for all of them we have a question and answer. For all of them we have. Now what you have to do is you have to practice all these things. Okay, so first you try to take the question, don't look out the query, and try to understand the question, and try to prepare SQL for the question, and see whether you are able to get the expected result or not. If the result is not coming, then compare your SQL with this SQL. What is mentioned in the document and what is mentioned in the what I have prepared. I mean what you have prepared. Compare with that, see the mistake, rectify it, and execute it. Okay, so these are all the so these are all commonly asked in interviews. Okay, because in our material what we are going to keep, so like the students whoever go for interviews, like uh, they'll be telling us, sir, they'll be calling to me and they'll be asking me that, sir, I got this question in the interview today, so can you please help me with that, because I could not able to answer there, but in fact I also tried it but I could not able to get a solution for it, so can you please help me with that. So when I'm going to help them, I'll be adding in the material also. So when you guys also, when you go for interviews, whenever you see any new SQL question, which is not there in the material, okay, so just let me know. So I can add in the material and then I'll share it to the upcoming students. Okay, so if you are thorough with these SQLs, okay, if you are thorough with these 30 SQLs, then you can crack any SQL interview in with scenarios. Okay, and theoretically, so there are some theoretical questions also. Those theoretical questions I'll be sharing in the Google Drive. I'll share the document in a Google Drive. Okay, and also I'll share in the WhatsApp. Okay,
Sure, Bhaskar.
just take that as a theoretical questions. Take these questions for scenario-based questions. So that if you're thorough with those theoretical questions and these scenario-based questions, then you can crack your first SQL interview. Okay. Any question? Anyone having any question?
Bhaskar, can you please share me the PLSQL like after this too?
PLSQL material I'll share. I need to search for it. Okay, somewhere it is. But yeah, I have a good material. Also, that is also kind of a practical material only. Okay, so I'll share that material.
Okay, Bhaskar, thank you.